Welcome to my channel. I'm Joan Amara, and today we're going to be learning about Laplace transform, but this video will be restricted to polynomials. Alright, so let's start. If you can see, I had taken time out to write the Laplace transform of a function of x will always produce a function of another variable, but for this video we're going to be using p. Okay, some people use s, some use t, but for this video we are going to be using p, and we're going to see that shortly. Let's quickly define what a Laplace transform is. Welcome again to my channel. Please kindly subscribe. Please kindly hit the subscribe button, like my video, and hit the notification bell beside the subscription button. Thank you. A Laplace transform of a function of x is actually defined as the integral from 0 to infinity of the product of exponential minus, these are variable p, x times f of x, that function you're trying to get the Laplace of, dx. Before we continue, I would like you to know that the Laplace transform cannot be gotten for every function, does not exist for every function. At least the function must be bounded, but I won't go into that detail now. Let's try to get Laplace transform of some functions that I'm sure exist. So we are going to take polynomials, okay, of degree. Exponential minus p times x times all times k dx. Now if you observe, we can't actually easily compute this, but we are going to be doing something which we'll be doing every time we want to take the Laplace of something. So we're going to integrate now from 0 to some b, and then towards the end we're going to take b going to infinity so that we can get this function. Okay, so we're just going to, for now we are going to just get the integral from 0 to b of exponential of, let's put k first now, k is a constant, so k exponential minus px dx. So you can see we can bring out k, right? So this is actually k, integral from 0 to b exponential minus px dx. So what do we do now? We integrate this. At this point I would like us to let u to be equals to minus px. This implies that what du by dx will give me what? Minus p. And if I want to make dx the subject of formula, it means that dx is actually equal to du over minus p. Okay, so we are seeing p as a constant. Okay, so if we substitute that into the equation, we have integral from 0 to b k exponential minus p times x dx. This is now actually equal to k integral from 0 to b, right, exponential minus px dx, right? So this is equal to k. Remember that this is actually x that is going from 0 to x going to b. Okay, so we can now substitute. This is exponential u du over minus p. This minus p can go out because it's not a function of u, so we can see it as though it's a constant. And then we have what? K minus k over p, right? If I integrate u, exponential u, if I integrate exponential u, I have what? Exponential u. x goes from 0 to b. So I just replace u with what we had, minus px. So we have minus k over p exponential minus px from 0 to b. So we are almost done. So what does this give me? This gives us minus k over p exponential minus pb, right? Exponential minus pb minus exponential minus p times 0. That's actually 0. Okay, so this will give me what? I can bring this minus in. I have k over p, right? I have minus exponential minus pb plus exponential 0 is what? 1. So now we are through. We can take limit. The Laplace transform of k is equal to integral from 0 to infinity k exponential minus px dx, and this is actually equal to limit as b goes to infinity of this. Okay, so that will give me what? K over p 1 minus, I just swap the position, okay, so that it can look more reasonable. 1 minus exponential minus pb. So this is equal to, this is a constant, I can take it out. Okay, so this will give me k over p limit as b goes to infinity 1 minus 1 over, you know that this has minus sign, so this is exponential pb. You know b is going to infinity here, so this is actually going to make sense only where p is bigger than 0. Okay, so if we take p to be bigger than 0, we are going to have what? That this whole thing is strictly increasing to infinity. That means this would, the limit of this whole thing will give me what? 0. Yes, so we can easily take that limit and this will go to 0. Our final answer will give us k over p 1 minus, this goes to 0, so this is 0. So this means that the Laplace transform of k is actually k over p. So let's see something in particular. So what is Laplace transform of 1? Yes, 1 over p. What is Laplace transform of 25? Good, 25 over p. Alright, the next step is what? We are going to consider x, right, raised to power 1. So let's see what this looks like. You know that the Laplace transform of 1 is the same thing as saying that Laplace transform of x raised to power 0. Okay, and this is what? 1 over p. Okay, let's move forward to getting the Laplace transform of what? X. So Laplace of x is what? Integral from 0 to infinity, this is an improper integral, of x times exponential minus p times x dx. So we are going to be evaluating this integral, and you know, to evaluate this integral is simply evaluating what? Limits as b goes to infinity, integral from 0 to b x exponential minus px dx. So how do we evaluate this integral? We need to use the rule of products, right? That integral of u dv is what? Equals to uv minus integral of v du. So here, what is our u and what is our dv? The best choice of u is polynomial before exponential, so we are going to take x as our choice of u. So let u be equals to x. What does this mean? It implies that if I differentiate with respect to x, I'll have du is equal to what? Du by dx is equal to 1. So that means du is equal to dx. Okay, now our choice of dv is whatever is left. So from here we have our dv. So we have dv is equals to exponential minus px dx. So what we need to do here is integrate. Okay, so we can get our v. We've done that integral before and we got what? Minus 1 over p exponential minus px. So we are going to be putting this into here so we can evaluate that integral. So what would that give us? Integral from 0 to b x exponential minus px dx is equal to u. What's our u? X times v is minus 1 over p exponential minus px minus integral of v minus 1 over p exponential minus px. And what is our du? Obviously dx. Let's not forget that we have a range. There is a tendency to forget, so this goes from 0 to b while this goes from 0 to b also. So what is this equal to? I want to rearrange this. Let this minus bring this exponential down so that we'll have what? Minus x over p exponential px. You see that the minus is gone. The minus pushed that exponential px down. So this is actually from 0 to b minus, this minus will go out. Okay, it becomes plus, right? 1 over p integral of exponential minus px dx from 0 to b. Okay, I'm going to expand this now, and then we know this integral already, so I'm going to open that too. So this gives us what? Anywhere I see x, I'll put b minus b over p exponential pb minus, anywhere I see x, I'll put 0. Obviously this whole becomes 0 because this is actually minus 0 over p exponential 0. That's actually minus 0 over p. So this will give me what? 0. Okay, plus 1 over p. If I integrate this, I still have what I had before, minus 1 over p exponential minus px from 0 to b. I need to open this up too. Okay, after opening that up, we are going to take the limit so we can evaluate what Laplace of x is. So this gives me what? Minus b over p exponential pb. Okay, at this point we are going to push this exponential down because of this minus sign, so that will give us what? Minus 1 over p squared exponential px. See that the exponential is now down and it's going to be going from what? 0 to b. So this will give me minus b over p exponential pb minus, when I put b here, I'll have 1 over p squared exponential p, x is here, so b minus, look at this minus outside, so this becomes plus 1 over p squared exponential 0 is what is going to be here, which will give me 1, right? So I don't need to do anything there. Now I have my answer for my integral from 0 to b. All I need to do now is actually get the limit as b tends to infinity, so I can get the Laplace of x. Laplace of x is equal to what? Limit as b goes to infinity of minus b over p exponential pb minus 1 over p squared exponential pb plus 1 over p squared. Now let's evaluate this limit. For this limit to make sense, we have to know that what? P is bigger than 0. Okay, first of all, if p is not bigger than 0, we start swingling and dwindling. So Let's just impose p to be bigger than 0 here. We have that what this is going to infinity, but it's like a variable, a polynomial going to infinity, while this is exponential, right? You know exponential goes to infinity faster than polynomials. But look at this, take a look at this part. You will see that p is multiplying b. That's a positive real number, so this exponential is not just raised to that polynomial. Now this part goes faster to infinity than this part. Let me take that again. This part goes faster to infinity than this part. So with that, you understand that this goes to what? 0, because this is a small number over a very very large number. This goes very fast to infinity. Okay, so we have what? 0. Okay, and then the same thing with this, but this is much easier to see. This goes towards 0, and then we are left with only this side. Therefore the Laplace of x is what? 1 over p squared, where p is what's bigger than 0. Now if you keep on doing the Laplace transform, I would have loved to take it to x squared, but I would challenge you to do that. When you get to using the product rule of integration, pick your best choice of u to be polynomial, that's the x squared, and see what it gives you. You might not need to do that twice. Okay, you might need to do that twice. Here we did it once, but you might need to do that twice. So I challenge you to do that and let me know what your outcome is. But in general, the Laplace of 1 or k is equal to k Laplace of 1. Okay, and this will give me what? K times what? 1 over p. The Laplace of x will give me what? 1 over p squared. The Laplace of x squared, try to get this yourself, will give me 2 over p cubed. And if we keep going, we'll see that the Laplace of x raised to power n is equals to n factorial all over p raised to power what? N plus 1. So that is our generalization, and p must always be bigger than 0 for each of these cases. Okay, thank you for reaching the end of this video. If you like this video, please hit the thumbs up button. Please share the video to your classmates, your friends. Subscribe to my channel also, I would really appreciate that. Hit the subscription button and the notification bell so that you'll be notified each time I upload a new video. Thank you for watching.